All right, we're looking at answers to AP test review number 4. Looking at problem number 1, they give me g of x equals the integral from 1 to x of f of t, and they've given us the graph of f over here. So first thing we want to do is find g of 4, so that means I need to plug 4 in here. So that means I'm interested in the area between 1 and 4. So the area under the graph between 1 and 4. So if I look at 1 to 4, I notice that this area and this area cancel out. So all I have to do is figure out this area. So I've got a little square right here, which is a 1 by 1 square. So that means this is 1. And then I've got a triangle that is 1, 2, 3 by 1. So that means this is 3 over 2, or 1.5. So I have 1 and 1.5, which gives me the 2.5. Then I've got -2. So from 1 to -2, we're going from 1 to -2. So since we're going backwards, that means the area signs are switched. So since my area is above, that means it's actually going to be negative since I'm going backwards. So this is a triangle that's a 1, 2, 3 by 1, 2, 3, 4. So 4 times 3 is 12. 12 divided by 2 gives me 6. I need to make it negative. That's where we get -6. Part B, I want the instantaneous rate of change of g with respect to x at x equals 1. So that just means I want g prime of 1. So g prime of 1 is equal to f of x. So derivative of g means I need the derivative of this. Second fundamental theorem of calculus tells me I plug in the x and I multiply by the derivative of it. So that's how I get g prime equals f of x. So then I plug 1 in. So that means g prime of 1 is equal to f of 1. There's the x value of 1, and I get a y value of 4. So that means g prime of 1 is equal to 4. Find the absolute minimum value of g on the closed interval from -2 to 4. So absolute minimum means I need to include the endpoints and the critical points. So I need -2. We can go ahead and do 1 since 1 is just going to be 0. And I need 3 and I need 4. So g of -2, which we've already found. So g of -2 we've already found is 6. G of 3, which is right here. So I need the integral from 1 to 3. So the integral from 1 to 3. I already know this right here is 2.5. And this is a triangle that's a 1 by 1. So that makes it a half. So 2.5 plus a half makes that 3. So that's 3. And then g of 4. I know that this and this cancel, so that means g of 4 is going to be the same thing as g of 2. And we said g of 2, whoops, I did something wrong. Yeah, g of 2. Where's g of 2? I thought we did g of 2. We did g of -2. We did g of 4. All right, that's what it was. G of 4, we already did g of 4. So g of 4 is equal to 2.5. Absolute minimum value, my smallest is -6. So that means the absolute value, minimum value is -6. Second derivative of g is not defined at x equals 1 and 2. So there's x equals 1 and there's x equals 2. Notice we have cusp there, so that's why we're not defined. Then it says how many of these x coordinates of points are, how many of these values are x coordinates of points of inflection of the graph of g. So points of inflection occur when the derivative changes from increasing to decreasing or decreasing to increasing. At 1, we change from increasing to decreasing. At 2, it's decreasing on both sides, so we don't change. So that means I only have a POI at 1 because f changes from increasing to decreasing. Number 2, which of the following represents the shaded area? So we're just finding the area between two curves. So that's going to be top minus bottom. So the top is D, the bottom is f of x. So D minus f of x, and we're going from A to B. So that's why we like B. Number 3 is just implicit differentiation. Derivative of x cubed is 3x squared. 3xy, I factored the 3 out, and then I did the product rule with x and y. So first derivative of the second plus the second derivative of the first. The first was x, so the derivative of x is 1, so that's why there's nothing there. Plus the derivative of 2y cubed, which is 6y squared times y prime, and the derivative of 17 is 0. I distributed 3 in here, and then here's my 2y prime, so I factored that out, which left me with 3x and 6y squared. Then I need to move the negative 3x squared and the 3y to the other side, which is what I did there. And then all I have to do is divide, reduce all these by 3, and we get an answer of C. 4, I need a u for x cubed plus 1. Derivative of that is 3x squared. I've got the 3x squared, so that means I'm dealing with 1 over the square root of u, which is the same thing as u to the 1/2. U to the 1/2 turns into u to the negative 1/2 integrates into u to the 1/2. Reciprocal of 1/2 gives me 2, so I need 2 u to the 1/2. So 2 times the square root of x cubed plus 1 gives me A. For what value of f does the function f of x equals x minus 2 times x minus 3 squared have a relative maximum? So I need the derivative to get my critical points. So I'm going to do product rule here. So first derivative of the second plus the second derivative of the first. Notice both of these have an x minus 3 in it, so I factor that out. So 2 and the x minus 2 is left. That's where the 2x minus 4 comes from. And one of these is left. That's where the x minus 3 comes from. Put the x and the 2x together gives me 3x. The negative 3 and the negative 4 gives me negative 7. So I get an x value of 3. I get an x value of 7/3. Put that in a sign line. Remember, you plug into the derivative for your sign lines. So if I plug in, I'm going to get a positive, negative, positive. We want a relative maximum, so that means we've got to change from positive to negative, which happens at 7/3. 6, if f of x equals this, then f prime of 0 equals what? So I need the product rule. First derivative of the second plus the second derivative of the first, and then I'm going to plug 0 in. So I plug a 0 into this. Excuse me. Plug 0 into this, it's going to give me -1. -1 squared is 1, and then I have cosine of 0. Plug 0 into this, I get sine of 0. Plug 0 into this, that gives me 2, and this should be -2, but it's not going to matter because sine of 0 is 0. And cosine of 0 is 1, so that means my answer is 1. 7, so we have the function f, where f of 1 equals 4, and we have on the graph of f, the slope is given by. So when it says slope is given by, then that means this right here is the derivative. So that means this is f prime of x. So find the slope of the graph of f at the point where x equals 1. So that means I need to plug 1 in here. Okay. Notice I'm also going to have to plug a y value in. Well, they gave me the y value when x is 1, which is 4. So I'm plugging 1 in there. I'm plugging 4 in there. When I plug that in, I ended up with 1/2. Write an equation for the line tangent to the graph of f at x equals 1, then use it to approximate f of 1.2. Well, I've already got the slope from part A. I've got my point right there, so that's going to be y minus my y value, my slope x minus the x value. Now I approximate for 1.2, so I plug in 1.2. 1.2 minus 1 is 0.2, and 1/2 times 0.2 gives me 0.1. So I add the 4 over 4 plus 0.1 gives me 4.1. So my approximation is 4.1. All right. So I'm going to solve the separable differential equation. So I'm going to move the y over, and I'm going to move the dx over, which is what I did here. Remember, separating is worth 1 point. Integrate this, gives me that. Integrate this, so the 3/2 stays. X squared turns into 1/3 x cubed. And integrate that, gives me 1/2 x. Don't forget about the plus c. I plug in my initial condition at this point and work it out. We end up with c equals 7. So I plug that 7 back in. Now all that's left to solve, all that's left to do is solve for y. Remember, that's only 1 point, so we're not going to freak out about it. So first thing I did was multiply everything by 2, and then I took the square root. Make sure we got to choose between the positive and the negative. Since f of 1 equals 4 and 4 is positive, then that means I want the positive square root. Use your solution from part C to find f of 1.2. So all I have to do is plug 1.2 in for my x's, which is what I did. Again, you do not have to work it out, so I'm happy with plugging it in and leaving it. Number 8, f of x equals sine of x over 2. Then there exists a c in the interval between pi over 2 and 3 pi over 2 that satisfies the conclusion of the mean value theorem. As soon as you hear mean value theorem, you should be thinking a rock equals I rock. So a rock is f of b minus f of a over b minus a. So f of b, which is that piece, f of a is that piece over b minus a. So that gives me pi on the bottom. This reduces to 3 pi over 4. This reduces to pi over 4. And this are both the square root of 2 over 2. So square root of 2 over 2 minus square root of 2 over 2 gives me the 0. So that means a rock equals 0. So now I need to set I rock equal to that. Well, I rock is just my derivative. So the derivative of sine of x over 2 is 1/2 cosine x over 2. Set that equal to 0. Multiply by 2 to get rid of this. Ask myself, when does cosine equal 0? Cosine equals 0 at pi over 2. So then I set the inside equal. I multiply the 2 over, and we get x equals pi. And again, remember, at the x value of pi, that's where the instantaneous rate of change equals the average rate of change. Number 9, the acceleration of the particle moving along the x-axis is given by a of t. If the velocity is 25 when t equals 3 and the position is 10 when t equals 1, then the position at x equals x of t is. So this is a two-part one. I need to figure out what velocity is. And then once I figure out what velocity is, then I can integrate velocity and I can get position. So here, to get velocity, I need to integrate acceleration. Integrate 6t gives me 3t squared. Integrate 2 gives me negative 2t. Don't forget the plus c. This is where I plug in the 25 and 3. So there's my 25, there's my 3. I solve it. I get c equals 4. Then I plug 4 back in here. Now I want to integrate velocity. So if I integrate velocity, I get position. I marked it as s first, but then I noticed that they're saying position is x of t. So if I integrate this, I get t cubed minus t squared plus 4t. Don't forget the plus c. I plug in 10 and 1. I plug in 10 and 1. As you see, I get c is 6. And there's my answer with my c value of 6. Number 10, I want the derivative of an integral. So we should know this by now. It's second fundamental theorem of calculus, which is 2 steps. I plug in the x and I multiply by the derivative. In this case, the derivative of x is 1. So really all I have to do is plug in the x and I get cosine of 2 pi x. Don't miss that one. It's super easy. All right, if f is a linear function, so that means f is a line such as like 3x, and a is between 0 and b, so a is between 0 and b. That just means a is positive, so a is positive, b is positive. Then the integral of this thing equals what? Well, if f is 3x, then that means the derivative of 3x would just be 3. Okay, so that means if I integrate f double prime, that gives me f prime. Well, we just said f prime is just going to be a constant. So if I plug in a and b into a constant, that's just going to be the constant minus itself, which gives me 0 every time. All right, minimum value. So that means I need a derivative, set it equal to 0. Notice it said minimum value, so that means I need to find the y value. That's the tricky part about this one. So first derivative of the second plus the second derivative of the first. This reduces to give me 1. I subtract the 1 over. I e both sides, so my x value is e to the negative 1, but we want a minimum value, which means I need the y value. So I have to plug this back into the original. When I plug it back into the original, I get e to the negative 1 times negative 1, which is the same thing as negative 1 over e. 13, we want a point of inflection, which means I have to go to the second derivative. So the first thing I did was rewrite both of these. So x to the negative 2, x to the negative 3. Derivative of this is negative 2, x to the negative 3. Derivative of this is 3x to the negative 4. I need the second derivative. So I'm going to get 6x to the negative 4. I'm going to get negative 12 x to the negative 5. I move these two exponents back down, or x to the negative 4 down to the bottom, x to the negative 5 down to the bottom. Common denominator, so I need to multiply this by x, so that's how I get 6x minus 12. Set that equal to 0, and we get x equals 2. Okay. 0, we might have thought that 0 could be a point of inflection, but if you notice, 0 makes my original function undefined. If it makes the original function undefined, it cannot be a point of inflection or a critical point. So therefore, I went ahead and did it for safety. I went ahead and did a sign line, but therefore my only possible answer is 2. Or actually, since I had at no value of x, I definitely needed to do a sign line to verify that the signs change. So that 2 is my answer. All right, so that is answers to AP test review number 4.